gives me a great pleasure to welcome you all to the second of the Tri-Series Maritime webinar being organized by INMEX SMM and Informa Markets in India. INMEX SMM India is South Asia's largest maritime event held biannually, jointly organized by Informa Markets in India and Hamburg Messe und Congress. And 2021 edition from December 15 to 17 will be the 12th edition of INMEX SMM India, and we'll see 3 days of exhibition complemented by conferences and targeted B2B programs. Let's have a quick look at the INMEX video.
The type of response which the world is giving to this exhibition is already showing that Indian maritime industry is picking up. There can be new B2B transactions which can take place through these exhibitions, and they're very, very useful.
It definitely compares favorably with the largest maritime conferences and exhibitions anywhere in the world. So in that sense, it brings us a lot of pride that such an event is happening in our, backyard.
Is basically here to come here and understand the advancements and the innovations in the shipping industry. And it was a great opportunity to network with the big names of the industry, and we really liked it here.
Excellent opportunity to meet our customers, where we have the opportunity to exchange information here on our stand and see actually a product outside of a ship.
Quite nice, well organized.
Good work.
Very nice. It was well managed.
Everything is fantastic.
Informa PLC is a leading international events, intelligence, and scholarly research group listed on the London Stock Exchange and a member of FTSE 100 with colleagues working in more than 30 countries. Our portfolio is comprised of more than 550 international B2B events and brands in markets including healthcare and pharmaceuticals, infrastructure, construction and real estate, marine, fashion and apparels, gems and jewelry, hospitality, health and nutrition, among others. Our webinar today on marine robotics and automation is of great relevance given the new technologies are big game changers in the shipping industry and offer huge potential. From managing the fleet and crew to automating time-consuming processes, Technology will enable shipping companies and ports to increase business performance, improve operational efficiencies, and drive down costs. We have with us an eminent panel to discuss the various aspects of marine automation and robotics. A huge welcome to our eminent panelists and moderator to include Mr. Pradeep Chawla, Managing Director, Group QHSE and Training at Anglo-Eastern Ship Management Limited and Chairman of Global Met Association. Mr. Avinash Rai, CEO of Adani Krishnapatnam Port. We have also have with us Mr. David Birwadkar, Advisor to the Great Eastern Shipping Company Limited. Also joining us is Dr. Arnab Das, Founder and Director, Maritime Research Center, Pune. The panel session will be moderated by Vice Admiral V. Kannan, retired from Indian Navy and retired MD and CEO of L&T Shipbuilding Company. A brief introduction of our moderator. Vice Admiral Kannan completed his BE in Electronics Engineering from College of Engineering, Trivandrum in 1973. Thereafter, he joined the Indian Navy. He subsequently did his MTech from IIT Mumbai and MBA from Jamnalal Bajaj Institute, Mumbai. During his 40 years of naval service, he held varied appointments pertaining to indigenization, QA, and DRDO projects. He was also the program director for India's nuclear submarine projects and nearly 4 years during which INS Arihant was launched. He retired from the apex post of Chief of Materials for Technical Officers in the Indian Navy. He was, during his service, conferred with 3 presidential awards, which includes Vishisht Seva Medal, Ati Vishisht Seva Medal, and Param Vishisht Seva Medal for his distinguished service. After retirement, he worked in the corporate sector as MD and CEO of L&T Shipbuilding Company at Chennai for 5 years. Presently, he has settled down in Coimbatore. Thank you very much, sir, for being with us today. I invite you to take over and conduct the session.
Thank you, Mr. Paul. Good afternoon to everyone. Right at the beginning, I would like to thank the organizers and Mrs. Inform Markets for giving me this opportunity. I have a short presentation to make. I'll just share the screen with you. So I thank once again the organizers and Mrs. Informa Markets for giving me this opportunity to participate in this webinar, which has been structured around the emerging technological applications of automation and robotics in respect of marine assets. I would like to focus on what are these areas on which we are going to talk about today. We have a group of very eminent, very professional experts to speak about it. But before that, let me tell, marine domain has a very prominent role to play both in nation's economy and security. So therefore, it's necessary that the marine assets are managed efficiently, operated safely, as well as they are environmentally friendly. For today's discussion, we have identified 3 major marine assets. They are ships, submersibles, and the ports supporting the ships which are going to sea. As mentioned earlier, sustained operations of these marine assets are very important for our economy, and therefore we need to look at the way they are designed, the way they are maintained, and the way they are managed, including from shore officers which are managing it through their satellite link. So when I'm talking about ships now, as mentioned, we need to have them designed and operated with a high level of automation. When the ships reach the ports, they need to be quickly turned around after their loading and unloading, and therefore the ports have to be suitably automated. They need to be provided with machinery which can operate with customized software depending upon what the infrastructure is, and thereby ensure a high level of productivity and safety in the port operations. The third asset pertains to submersibles. Now, submersibles are normally deployed from a mothership. As shown in the slide, there's a mothership as well as the submersible. Most of the submersibles are unmanned, and they have a very high degree of automation, and some are equipped with even robotics for operations in mining, it could be in salvage, it could be in rescue. Submersibles are becoming increasingly relevant for various underwater missions which we take. It could be for R&D and it could be for security surveillance, and they have great economic importance as well. To give you all a very concise and sharp analysis of the extent of automation and robotics in these assets, we have with us today 4 speakers, and each one of them would be making a short presentation, on completion of which we'll have a combined Q&A session at the end of the 4th talk. The first speaker would be Mr. Pradeep Chawla. I will introduce him a little later. He is going to speak on automation and robotics as it is prevalent in today's ships. The next speaker would be Mr. Avinash Rai, who would focus on automation of ports and how it enables ease of doing business and a high level of efficiency in E2E logistics. The third speaker would be Mr. David Bidwadkar, who would give developments and advancements anticipated in tomorrow's ships, how these technologies is going to evolve and how they would provide us with a higher level of efficiency and productivity. So he's going to talk about tomorrow's ships. And the last speaker would be Dr. Arnab Das, who would take us to the underwater domain and familiarize us with the automation and robotics and their applications in submersibles, mostly in submersibles. I will introduce, as I mentioned earlier, each of the speakers just before their individual talk. With that, let us start with the first speaker, Mr. Pradeep Chawla, who is going to speak on today's ships. While I introduce Mr. Chawla, I request him to get ready with this presentation. I'll stop sharing here. And Mr. Pradeep Chawla is our first speaker, and he is going to focus, as I said, on present-day ships. He has nearly 50 years of experience in the marine field, and a significant part of it has been when he has been out at sea. Later, after he left the sea billet, he has been working with very leading companies, and out of which Anglo-Eastern Ships Management for over than 3.5 decades. He's a group managing director of quality, health, safety, environment, and training, and is presently based at Hong Kong. More than crew of 1,000 ships have gone through his training institutes, and he must be a very satisfied man seeing his students are out at sea all over the world manning ships. He has brought in a lot of digitalization in training on marine subjects, and he has conceptualized IT-based training by which it's possible for taking the classes from remote locations, including practical aspects. And he is a member of various expert committees and advisory committees, including some of them being for the government of Hong Kong. He has even authored a book in Hindi, of course, titled Jahaz Par Suraksha. So he comes with a lot of experience. As I mentioned earlier, more than 5 decades of experience in this field. And now I request Mr. Pradeep Chawla to give his presentation, automation in shipping. Mr. Chawla.
Good evening, everyone. It gives me great pleasure to be on this one, and thank you to the organizers for inviting me for this panel. I wish it was in India. I obviously miss the vada pav and the pani puri and rasgulla that go along with the trip to coming to India. So it's unfortunate that we all have to do this all over online stuff. Now I've been given strict instructions by Padma that my shoulders have to be visible all the time. So if it is not, let me know. But don't worry, I'm not going to take my shirt off like Salman Khan. So this is on instructions. I'm sitting on a couple of cushions in order to do that. Okay, let's start. Here we go. So what are the buzzwords today in our industry? It's always digitalization, autonomous ships, machine learning, AI, predictive analysis. There is no IT company in the world today who doesn't include these magic words into the presentations that they come and give. How much of it is solid and how much of it is all something in the future is still to be seen. So let's make it clear. I'm not going to talk about autonomous ships. I am part of the IMO group on the regulatory aspects, but this is something that we are looking at minimum of 20 years. There are going to be papers in the next MSc trying to expedite it, but we are not going to be looking at this in the near future except in the short sea trade. So what we are going to talk about today is automation. Now, just so that it's very clear about what I am calling as automation, it includes telemetry, everything to do with satellites and VSATs and all, the pipelines, the communications, sensors, process measurements and control, everything to do with system integration, and more importantly, the insights derived from whatever data we collect. So the products that we are seeing in the market now for shipping are pretty much can be captured by this wonderful graphic that I borrowed from Kongsberg. So there are products about propulsion control, power management, alarm management, machinery management, a few nice products on navigation, and slowly the integration of the cargo management systems and ballast management systems is also to be seen. At the moment, we have one ship which has all the tank gauges and transfer of liquids from one tank to the other all being recorded and can be seen on the cloud in the office. So the general drive that I see in the industry now is really to get data from all kinds of machinery systems, mainly through alarm monitoring systems and adding sensors to different kinds of machinery. Now the packages that go with this kind of a thing can range anything between $15,000 to $100,000 for a complete set of sensors. There are also companies who kind of say that we can more or less do the same thing on fuel efficiency, etc., without adding too many sensors, because we have these intelligent AI-driven algorithms which can function in the same way. So the ones who are kind of selling stuff with sensors will tell you that you can't do anything accurately without sensors. And the ones who are selling products which are without sensors will tell you the sensors never work, etc. So I have another slide later on about it. So what do we see? The most common kinds of focus that we see now is in terms of route planning and optimization, which brings in all the weather layers, etc. On the nautical side, it can be combined with cameras. I think I have a slide on that too from one of our ships. And then we see, yeah, that's the next one. So this is cameras, 120 degrees, 1.5, 2 miles, a bit of augmented reality. In one company's products, you have augmented reality, the other one doesn't. And they help in decision making for the master with these situational awareness improvement products, I would like to call them. Not too many people in this sector right now that are selling commercial products. I know that the armed forces have a lot more products than in the merchant navy. The focus mainly is on fuel efficiency and these kind of products which can kind of compare all kinds of things, different performance of different sister ships, class of ships. All this is becoming more and more kind of easily available, and there are more than 20 companies presently in this sector who are all selling the same kind of stuff. And then you have these kind of companies who are bringing all the data from main engines, auxiliary engines, and they give them to you in the office with all the gauges, temperatures, pressures, etc., etc. Now the focus of these companies kind of is to say that there will be better decision making because the vessel manager and the chief engineer on board are looking at the same data. They also promise that there will be predictive analysis of machinery failures. I guess that's coming, but once there is a lot of data already in the system. And in the meantime, maybe they will focus on the areas of condition-based monitoring rather than plant maintenance systems. We also see products which are coming in with respect to just-in-time arrivals of ships. Now, this is obviously the ecosystem has to be built around that you would save fuel if you didn't have to speed up to the next port and wait there a tanker for 7 days. So that kind of systems are also being integrated. It's all started with the sea lanes projects in Europe, and now we see that there is more and more interest on it. We as a company have been participating in these trials for these kind of services. And I think coming soon in the future will be benchmarking. I mean, all the global fleet data somewhere in a data center, and which will be accessible to different stakeholders. And there will be a lot more kind of benchmarking with more data. So right now shipyards don't really share data amongst each other. Neither do electronic equipment manufacturers. But somewhere down in the future, we see that there will be products that will be coming out anonymized, but giving some benchmarking to the industry. But I think the challenge for any industry, so it is right now in infancy, the whole digitalization space in shipping. We are a conservative industry, so we've taken longer than the other industries to get on board. But the simple fact is that these companies will need to save money or do something to save the environment or do something to make the ship owners buy it, because ship owners typically would first like to see what do they save or what do they gain by these new systems. So what are the challenges for these kind of companies? I would say the first challenge is really on this whole business of sensors, reliability of them, sturdiness of them. Maritime conditions are different. We are taking off-the-shelf sensors quite often. The vibrations on a ship, the slamming, rolling, pitching, higher humidity, high temperatures in the engine room, all that kind of stuff. We are still kind of experimenting to see which sensors would be the right ones to do, and slowly we will get there. And then of course, the sensors on land-based installations are not fitted on a flexible girder. They're not flexing. The whole hull is not kind of flexing in a factory. So that's another challenge that will be there for bringing about sturdiness and reliability of the sensors. And we still have a problem that IMO doesn't really have any industry standards at the moment for this whole business of what kind of sensors to be used, which prevent shipyards kind of into offering these things. There are shipyards, like I said, we have a ship with all these sensors, but there are not many shipyards giving this as a standard package. Then the next problem that I see, which is not yet fully solved, is that ships could generate trillions of points of data, and this could be as much as 50-100 GB in a day if we start integrating all the systems on board, bringing them to the cloud, etc. And the pipeline that we have today, an average ship with a VSAT, and even that, or not all ships have VSATs, an average ship would have a data plan of 2 Mbps. Compare that to your home internet line, and we won't be doing Zoom so comfortably if we had only 2 Mbps lines, and the cost of that compared to a home line versus what's on the ship. So this is still something that needs to be solved, and when we have the Starlink kind of low orbit satellites, maybe things will come down in pricing and in improved speeds. But the average speed nowadays is only about 900 kbps on the standard plan. And there are little holes in the coverage between KU band satellite systems. Inmarsat with high orbit satellites is more coverage, but the KU and KA band people are all kind of saying this mine is better. So where we go with it is still, there are a lot more things that can be improved on the data connectivity. And then we have the bigger issues. The regulatory framework of any industry for this kind of a thing takes a long time. And as you can see, the first car that traveled across the US East Coast to West Coast, driverless, was in 1985. Wikipedia research. No geniuses to guess this. And we still don't have the issues. And there are new issues with the Tesla autopilot, new investigations going on by the US. So we still don't see them on our streets all over the place. And I would love to see someone designing a driverless cars in the traffic of Mumbai. That would be the ultimate challenge. So let's see where that goes. And then we also have the issue about the mindset of people. How much will we accept as a society? Do we want an LNG or an LPG carrier or a VLCC coming into our port, completely autonomous? Not in the present scenario, I would say. Someday in the future, 20, 30, 40, 50 years, yes, surely that will happen. How do we get people who are even reluctant to change from paper charts to ENCs and egg disc? There are ship owners like that. How do we get them to change and adopt the mindset? As we all know, it's a bell curve. Only 10% of the people are early movers, the innovators, and the last 10% are the most difficult ones to get. But the other ones will kind of move when the technology becomes cheap enough and good enough, mature technology, people will move to it. So cybersecurity, still lots of issues there. Another big issue is about data ownership. There's going to be plenty of working groups around in the world. I'm part of one where people will argue about to whom does this data belong? To the ship owner, to the guy who's collecting it, to the manufacturer of the engines or the equipment. So this is still something to be solved. So now coming to my conclusion about it, what do we need to have it focused, especially in the context of India, since I guess the majority of the audience today is from India. So first of all, the competencies of the people. We are a cruise supplying nation, and we need to train people for the future. And Anglo-Western works quite closely with DG Shipping in trying to revise syllabuses many times. And we will need to look at how do we get people who can derive insight from all this data that we are getting. We will need people who are able to process large amounts of data in their mind, who are able to focus on critical issues. That's the screen of one of our ships on an alarm, and you can see the number of red lines that come in whenever there is something going wrong. How to focus on the right thing. So there is something called alarm fatigue that all these automation system people need to look at. And of course, the ability to work with remote teams. We are all, Anglo-Western also has an operations center in Mumbai. And now the master consults with them, and all this remote discussions, rather than being lord and master of the ship, discussing with people ashore is part of it. So what is certainly needed is a collaboration of companies. We need to create a cluster of companies who are innovating in India, who are willing to work together in this digitalization space. And what we see the pattern in other parts of the world is that there is a defense and industry partnership, and there is a national program behind it. And right now, I would say that I have yet to see evidence of that, and I guess there is a 2030 document being written in India for the vision for 2030 in maritime vision, and I do hope that all this is taken into consideration if India needs to be in the game with the other clusters, which are mainly Japan, China, and Scandinavia, US, and the UK. How do we compete with those clusters? We have the best software talent in the world, but do we have the right framework created in the country is what I would like to leave behind as a thought for the participants. And are we going to miss the boat, or are we going to get on to this one better? We missed the boats in many other areas, shipbuilding, etc. in the past. We're catching up. Are we going to be ahead of the game, or are we going to be behind and do play catch up? Thank you.
Okay, thank you, Mr. Traveler. Now we go to the next speaker. That is Mr. Avinash Rai, who is presently the CEO at Adani's Krishnapatnam port. He's a mechanical engineer by qualification, and he has had more than 30 years of experience in steel plants, aluminium plants, metallurgical complexes, and his senior position the last 10 years include, he was a unit head in Vedanta Resources for a long time. Thereafter, he was Chief Operating Officer at Bharat Aluminium Company. Thereafter, he was again Chief Operating Officer at Mundra Port of Adani for a long period of nearly 6 years. And now he is CEO of Krishnapatnam Port, which is again the Adani Group. I now welcome Mr. Avinash Rai to give his presentation on automation in today's ports and how they can be improved upon to support the ships and the ease of doing business. Mr. Avinash Rai.
Thank you, Mr. Kannan. Thank you, Mr. Pradeep, for such enlightening views on the marine automation. So I'm picking up from where Mr. Pradeep has left, is what is done on the vessels to what is done on the ports. And the basic philosophy for automation at the port rests on 3 pillars. And those pillars are safety, information systems, and efficiency. How do you look at the business at the ports when the vessels which are coming are becoming bigger every day? The container vessels, which were before 4,000 TEUs, today 20,000 TEUs, are becoming standard on the transatlantic and other areas. In India, 14,000 to 16,000 TEU vessels on container have become a standard. And how do you improve the business on those in terms of safety? That's the first pillar. How do you do that? When it's a carrying of cargo up and down the vessel, where every vessel wants to turn around faster. The key is reducing the level of manual intervention in the processes. And how do you do that? Is by doing automation of the repetitive processes. And which are the processes which are being handled in the terminal? Is the container loading, unloading? Is the horizontal and the vertical transport of the containers? And this is where the first experiment started in the world in Holland, where the automated terminal started sometime 2 decades back. And today also the technology is being perfected. Slowly, this is spreading across the world, where automated terminals are coming in to reduce the fatigue on the people and to reduce the man and machine interface. A person has his productivity ups, has his productivity downs, and automated control works at the same pace. So that's the key on improving safety, where automation of the cranes and the RTGs which are handling these containers is being brought in the world. Second is tracking maintenance on machines, on ships, and predicting failures. This is one which again improves the safety, which Mr. Pradeep mentioned in his presentation of how do you bring maintenance and predict the operation and safety. The other one is the information systems. Getting a vessel from across the world, carrying cargo across the world, how do you do business is providing an interconnected world. Today, every port, every vessel, every line runs on a system. But the key is how do you connect your systems to work or interface with each other's at a pace, at a speed, without intervention. And this is where the key for across the world is building in digital platforms, which converts the old manual and paper-based data into digital form, access for all the users. This is also a need which has been accelerated in the last 1 year with the COVID coming in. Before, everybody was comfortable visiting the offices, visiting the various departments, various locations, which as a need has accelerated the digitization of the whole shipping business. How do you get everyone when a single box could have as great as probably 8 or 9 stakeholders in the system, right from the cargo owner to the vessels, to the custom handling agents, to the cargo owners, to the transporters, and everyone who is involved in this chain in delivering this cargo. This is where the digitization is helping the industry today. And it's a time when you will see very soon in India a super app sort of thing getting developed, which comes as part of National Logistics Portal, where everyone who is engaged in the business of shipping is able to conduct their business there. It is the banks, it is the customs, it is the vessel, it is the cargo. Everyone is able to conduct their business in a seamless manner, which reduces the cost of business, which accelerates the pace of business, and which makes the business smooth. The other one topic is streamlining and optimization of both maritime assets and intermodal assets. And what are those? A vessel which comes into a port wants to be turned around faster. A trucker who is coming in to bring or take a container wants to return faster. The shipping line, which is the owner of this assets container, wants the containers to travel the least on empty mode. So this is where the container triangulation from empty to load is an automation activity which is picking up across the world. The other aspect is, what do you do with all of this data once you have digitized, once you have integrated? The integration of all of these systems is throwing up reams and reams of data which comes out of the port community system, harbor masters, customs, terminal operators, shipping lines. And the biggest key is to use this to monitor the performance and improve the productivity. Every process, every parameter can be looked at to improve its performance. And how do you do that? Is a continuous benchmarking against yourself, against your competitors. This is the biggest advantage of the digitization, which is continuously helping ports today to improve their performance, where every day everyone wants to extract the last rupee out of the process. How is it being driven? This is being driven by the initiatives taken by the government and the private enterprises who are coming together to integrate all their applications. This is coming as part of National Logistics Portal, whether we talk of IceGate, whether we talk of third-party platforms which are offering service. All the shipping lines today are ready and offering an online cargo booking system. But how do you integrate these systems with the bank systems, which are offering the letter of credit? How do you integrate this today with the customs system? And this is the biggest opportunity today for us as a country to bring all of this integration, to bring a real-time visibility. The cargo at every stage of the process is visible to the owner. He can plan his activities better. He can plan his factory assembly lines better. And the second biggest advantage is reduction of redundant data entries, making data acquisition reliable, cleaner and faster. This is the biggest opportunity today for India, which is leapfrogging in bringing an ease for doing business for everyone in the trade. The last pillar of this is improving the efficiencies. And how does it do that? The real-time berth planning is one biggest asset today based on the maritime information, based on the AIS signals. The vessel arrivals can be predicted to a very great extent. And how do you use this information? You can use this information to plan the resources, to allocate the resources, which are in terms of cranes, in terms of trailers, yards, and it decongests the paths and routes, eliminating the killing time, which is the waiting for resources, waiting for usage. This is one of the biggest costs in the system, whether the vessel is waiting for the berth or the berth is waiting for the vessel. Ultimately, it is money which is not being produced. The second biggest efficiency which comes in is establishing the predictive maintenance of assets. Based on the usage, based on the arrival, and based on the pattern of wear and tear, this is where all the so-called sensors which are coming in on the equipments, being brought on the equipments, and throwing up the data to bring a repeatability in the maintenance of the assets to deliver peak performance. The other is the continuous surveillance of assets, which allows you to monitor the assets for status changes. And this is one of the biggest opportunities today in the industry to reduce the cost for business, thereby improving the efficiencies. And the next is energy savings, which is being driven by elimination again of the waiting time and eliminating empty runs. eliminating the shuffling moves in the yard, bringing in lighting load optimization, which is one of the biggest costs in the terminals in terms of energy consumption. And all of this also brings improved sustainability in the whole shipping business by reducing the energy consumption, improved productivities. Every such process standardization by use of automation removes the judgment factor or the hero factor that only when this person is there it can be performed. It makes the process repeatable. It makes the process stable, and this allows the highest of the productivities to be achieved in the business and increases the handling capacity of the infrastructure, thereby reducing the cost of doing the business. In short, automation is a key factor today, which is allowing everyone in the business to improve the efficiencies, improve the sustainability of the business, and reduce the cost of doing business. Thank you, everyone.
Thank you, Mr. Roy. Now, there is a very good presentation, and I'm sure there'll be some questions which will come at the end of the fourth talk. The next speaker is Mr. David Bilwatka, who's presently an advisor with Great Eastern Shipping. David is a mechanical engineer by qualification, and he has been associated with shipping and maritime activities for over 40 years. And he was engaged in leading ship management companies like Wallams, Essard, Anglo-Eastern, and for a long time thereafter with Great Eastern. He was vice president with Great Eastern for over 15 years, whereafter he is now an advisor with them. He is going to speak to us on what ships would be like tomorrow. He is going to make an assessment on what level of robotics and automation will come in ships of tomorrow. Anyway, the whole world is going digital, and therefore, how does this impact ships and their management from shore? So let's hear to Mr. David. Please give your presentation.
So my presentation is visible and I'm audible, I hope everything is okay. So Vice Admiral Kannan, other esteemed panelists and friends, a very good afternoon to you. Delighted to be part of this forum to speak on marine robotics and automation and the future ship, and would like to sincerely thank the organizers for same. So this is my brief agenda for today. Marine environment. The marine environment represents a challenging framework for the exploitation of cutting-edge automation-related methodologies and technologies. The oceans cover more than 70% of the Earth's surface and supports an estimated 90% of the life forms on our planet. Marine transport is a backbone of international trade and the global economy. Around 80% of global trade by volume and over 70% by value are carried by sea and handled by ports worldwide. Thus, the quest for the use of advanced technological tools such as remotely operated vehicles and fully autonomous robots and ships to improve the capability and enhance the human knowledge on such a wide and mysterious environment is utmost necessary. Maritime and naval applications such as ship monitoring and maintenance, emergency operation support, offshore inspections, and other related activities can also benefit from scientific and technological improvements on advanced technologies for ocean exploration. So what are the challenges with automation and robotics in marine? As in the case of space exploration, the ocean environment places formidable challenge in the development of autonomous and or persistent systems for exploration and sampling. In fact, engineers and scientists must strive to meet the extremely tight design constraints imposed by the harsh conditions that both surface and underwater platforms must face. Some of these are high pressures and low temperatures related to extremely deep or harsh environments. Example, the abyssilla, that is the seabed, polar areas require suitable components and watertight containers and equipment. Underwater communications mandate the use of acoustic devices that in challenging operational scenarios are plagued with intermittent communication losses and multi-path effect and exhibit reduced bandwidth and low reliability. Low-range missions require that the vessels be equipped with proper power supply systems, also relying on alternate technologies like fuel cells, biological batteries, solar panels, etc., and efficient energy management systems. Automation in marine transport. In a world characterized by an automation level which increases at fast pace, transportation means and infrastructures are also subjected to innovation. In recent number of years, A number of projects have been proposed with the aim to firstly evaluate the major issues and current technological limitations towards the employment of self-navigating autonomous ships such as MUNIN, that is Maritime Unmanned Navigation through Intelligence in Network project. Since currently it is not possible to test autonomous navigation for real ships in large scenarios, the activity has focused on developing suitable and reliable infrastructures aiming at trials at least confined in constrained and controlled areas. Autonomous shipping does not focus only on self-navigation of the ship itself, but the concept embraces the extension of common operations through the exploitation of autonomous agents capable of extending the operational range of the ship, allowing wide-range sensing, outboard interaction, and self-maintenance. So coming to the topic of autonomous ships. Just as artificial intelligence and autonomy promise in other applications, it is expected that autonomous ships can improve safety, increase efficiency, and relieve humans from unsafe and repetitive tasks. According to a study by Alliance, between 75 to 96% of maritime accidents are caused by human error. So if autonomous and semi-autonomous systems can help reduce the reliance on humans that are liable to make mistakes due to fatigue, bad judgment, autonomous ships could eventually make our oceans safer. Even if we have crew on board, the data gathered from the ship's sensors combined with artificial intelligence algorithms will help the crew make better informed decisions. A reduction of elimination of crew reduces the personal and auxiliary costs such as onboard provisions and insurance on a voyage. Typically, crew-related expenses account for 30% of the budgets. There are also efficiencies realized in ship design and use of fuel. One study projected savings of more than $7 million over 25 years per autonomous ship from fuel savings, crew supplies, and salaries. Since there are significantly safety concerns, especially with enormous size of most ships operating in congested waters, there's a lot more testing to be done and regulations to be sorted out before we see fully autonomous vessels operating without a crew. Much more likely is that automated technologies will be used to reduce crews and help the crew on board make effective decisions. In addition to ensuring the safety of ships, there needs to be a resolution about the regulation of our shared waters. Existing international conventions were created under the assumption a crew would be on board. In response, the IMO has kicked off its work to assess and update conventions to ensure safety in a new reality when AI is the captain instead of the humans. Until there is significant interest in fast-tracking research, development and updates to regulations for autonomous ships, the industry will likely learn from the decisions made on land regarding autonomous cars and then apply to the autonomous ships. Adoption and acceptance of autonomous cars in the coming years may put pressure on finding the same solutions for the sea. Automation in ship inspections. Coming to automation in ship inspection, large ships such as are difficult to inspect because of the surface area and in material and colors. It can be challenging to detect corrosion and other serious complications, especially under the water where it's dark and murky. It means that human inspectors have to inspect considerable time, poring over every inch of a vessel. What if it could be taken care by advanced robotics, not just more accurately, but faster too? A student team from ETS Zurich and ZHDA has joined up with Alstom Inspection Robotics to come up with a lightweight, versatile ship inspection robo. The prototype called Ship Inspecting Robo or SIR can scan over ballast tanks and hard-to-reach places on larger vessels. It has 4 magnetic wheels with an overlapping wheel base that allows it to move around the underbelly of a ship, even around I-beams and other obstacles. Remote operators control the robo with a wireless transmitter, which also sends a live video feedback to the command station. 4 infrared sensors measure distance and detect various obstacles or edges. SIR is not the only robo being developed for this purpose. However, MONAS, the Maritime Inspection Robotic Assistance System, and INCAAS inspection capabilities for enhanced ship safety are 2 European-based projects of similar nature. Bluefin Robotics is working on an underwater robo called HUAV for the US Navy. SmartBot is working on one too called RoboShip, which can inspect ballast tanks and perform maintenance underwater. We come to other important aspects of ship operation like automation in anti-piracy measures. We know how piracy is affecting shipping adversely, which can cause loss of life, huge loss of revenue, and other global impacts. The Recon Scott Throwbot by Recon Robotics is a small dumbbell-shaped robot that can infiltrate the main deck of a boat for stealth inspections. Magnetic wheels allow it to crawl up the side of a ship onto the deck and maneuver around. Cameras enable the operators to see what's happening in real time, even during the night, thanks to infrared sensors. It is all controlled via a joystick-based command unit. The US Navy recently awarded Recon Robotics a contract to develop the Recon Scout XP micro robot for them. Other aspects of ship operation, hull cleaning. We know how critical hull cleaning can be because of the savings in fuel and better speed if in case the hull is cleaned regularly. But underwater cleaning is also a task that can be dangerous, challenging, and tedious. Traditionally, divers perform their work while the ship is moored in port or dock. The hull bug is an example of an underwater hull cleaning robo. This 30 to 40 kg robo attaches to the bottom of the boat for surface cleaning and creates a negative pressure vortex and moves along the boat surface using a combination of rotating brushes and water jets to clean the buildup. A brief conclusion: the overgrown hull has a key effect on fuel consumption and therefore on the number of harmful emissions. Timely cleaning of the body can reduce fuel costs by up to 12% and can be more effective with robots rather than use of underwater drivers. Then there are other aspects of ship operation, that is robotics in weather prediction and navigation planning. It is a navigation planning for ships and vessels, marine digital force route planning based on geo, storm, and weather conditions. It lays the optimal route not only along the shortest route, but also data on the storm, geo, currents, waves, and other weather conditions to calculate the safest and most economical route for the ship to the port of destination. It will largely eliminate the error caused by human beings. There's another issue which is very, very critical for ship operation, which is firefighting. So use of robotics in firefighting is also has been conceptualized. Shipboard autonomous firefighting robot, that is Saphir, developed by Naval Research Laboratory in collaboration with Virginia Tech and other US universities. It's an autonomous humanoid robot capable of detecting and suppressing shipboard fires and working shoulder to shoulder with human firefighters using advanced sensors. The idea is not to replace humans in firefighting, but to aid them in firefighting operations on ship. In the case of fire on ships, these robots will perform tasks such as turning valves, picking up and dragging fire hoses, and putting water on fire. This concept can make use of different fire suppression technologies. The firefighting robot has a vision system to search for survivors and can withstand heat up to 500 degrees Celsius. It is also outfitted with multimodal sensor technology for advanced navigation to overcome obstacles and stay upright even in pitching and rolling conditions. The robot can respond to gestures and commands, and its sensor package includes a camera and gas sensor. Infrared and ultraviolet camera help to see through the smoke and detect the source of excess heat respectively. Several demonstrations and experiments on Saphir have been conducted in the past couple of months with an objective to enhance firefighting abilities of US Navy. This service can also now be used to tackle or fire in commercial vessels and offshore platforms in the future. Another important aspect is oil spills cleanup. Each year oil companies remove approximately 3.7 trillion gallons of oil from the earth. This oil is transported by barges, ocean-going tankers, and pipelines to refineries and storage facilities. It is inevitable that accidents happen and oil leaks and spills take place. Since oil is mostly transported across vast oceans, the likelihood of an ocean spill is inevitable. Oil spilled by damaged tankers during cargo and bunker operations on board tankers and other ships, and pipelines or offshore oil rig courts, everything it touches, and becomes an unwelcome part of every ecosystem it enters. Oil spills result in both immediate and long-term environmental damage, and the damage caused can last for decades after the spill. Oil floats on water, spreading out rapidly across the water to form a thin layer, and we call it an oil slick. As the oil continues spreading, the layer becomes thinner and thinner, finally becoming a sheen. When the oil eventually begins to sink to the marine environment, it can have damaging effects on the fragile underwater ecosystems. This is where oil-eating robots can come into play. The Global Response Group Corp, that is GRG, AEROS, Airborne Emergency Response to Oil Spill, the world's first and only robotic unmanned aircraft deployed safety-guided, satellite-guided oil spill emergency response. Rapid containment and recovery system. The AEROS is a fleet of airplane-deployed robots can contain oil. This system has been found very innovative and has been largely successful in containing oil spills. But though in an innovative stage, it looks that it will be the one for the future. Looking at the outlook of the world, current forecasts indicate remotely operated local vessels will be in operation for next few years, followed by unmanned ocean-going vessels in the near future. This will have significant implication on the nature of work in the maritime sector. Of course, we will have lesser and lesser crew, and finally crewless ships once it is found to be successful. The vision for the future is 2020 is just reducing the crew, 2025 in the coastal areas, and so on and so forth. So as Captain Chawla said, it is not going to happen so soon. It will take a lot of time before we finally have fully autonomous ocean-going ships. Looking at the outlook of India, Maritime Vision 2030 document has no mention of autonomous ships. Indian shipyards or shipbuilders are not planning any autonomous ships designed for the next 5 years. It is desired that India to keep up with the shipping developments worldwide and move in line with them. Indian ship owners also, to be more competitive, would need to look at modernizing their ships or acquire ships with advanced automation. Thank you so much for your time and have a great evening.
Thank you, Mr. Bidwadkar. Now we go to the fourth speaker, Dr. Arnab Das. Arnab Das is the founder director of Maritime Research Center at the Indian Maritime Foundation. His research work on underwater domain awareness has been widely appreciated. He's an electrical engineer by profession who was specialized in underwater electronics. He did his MTech from IIT Delhi and subsequently did his PhD as well from IIT Delhi. He served the Indian Navy for nearly 20 years. Today he is engaged in research work at the Maritime Research Center. He's also a visiting professor with Defense Institute of Advanced Technology. Now I'll invite Dr. Arnab Das to give his talk.
Okay, so I'm going to be talking about the underwater domain awareness framework, as I said. Going ahead, so I'll be covering under these heads. The 21st century global order, it is important for us to appreciate that the larger part of the maritime interactions or maritime activities are in the tropical waters. So as we can see, the 21st century, the larger maritime activities are in the tropical waters. And there are three things I would like to bring here. One is that, the activities in the tropical waters. The second is the larger underwater technology development that happened globally was in the temperate and the polar region. So the same technology does not work or has a severe degradation when we apply the same set of instruments or same set of sensors in the tropical waters. So it is very important that we focus on site-specific local R&D. We need to understand the tropical waters and then devise, the hardware would be the same, but the algorithms which will ensure better detection or better classification will have to be the ones which are developed in the local waters. Please go to the next slide. So the larger strategic construct that is being talked about today is the Indo-Pacific. It is related to political, economic, as well as military activities. So just an amplification of what I said, this entire Indo-Pacific is defined in the tropical waters of the Indian Ocean and the Pacific Ocean. So, and particularly when we talk about India in the 21st century, there are some of the issues. When I say underwater domain awareness, it is not just the maritime or the marine, but also the freshwater systems. So we, in the 21st century, do need to take into account the water resource management, water quality management. The Sagar Vision has been a very major declaration by the Honorable Prime Minister. What does it translate to on the ground? The security and growth for all in the region. Then to support the Sagar Vision, there has been announcements of Sagar Mala, Bharat Mala, and also we need to take into account the young India, which is aspirational and energetic. So what do we have for them? And particularly when I'm talking about the digital ocean, when we say water resource, these are open source data. By 2030, we are definitely heading for a huge water shortage. The supply and demand gaps are going to be extremely high. And you can see from the image, it's across the country. There are very few places in the country which are going to be surplus or comfortable. The second is the water quality. It is not just the availability, but also, when I say quality, I've just shown you a biological aspect, disease that have been detected and some of the data that is available. But even in terms of pollution, in terms of chemical pollutants and various other aspects, there is a huge, I think the water that you get in for domestic use in your house, you must know what the quality is it, and also these two are interconnected because the water resource management, the water that is supplied for domestic use and the industrial use cannot be the same. I mean, how do we distinguish this? And I mean, that will give us better water or efficient water resource management. So the water quality management and water resource management have to go together. Now, coming to the shipping, I mean, I think the focus here has been largely the shipping activity. One of the very important focus of the IMO also has been noise underwater. I mean, distribution of shipping and the number of vessels in water. Last 50, 60 years, the data shows that every 10 years, the low frequency noise because of shipping has been doubling every decade. So 3 dB increase every decade. And it's a very, very huge issue now. And IMO has taken cognizance of it. This year, MEPC 76, our paper was presented, India's paper on how to manage this. I want to give you an example of how automation can help. This is a map that has been built from the AIS data. AIS, as you know, gives you the entire details of the ship, both static and dynamic data. That has been, I mean, the entire region has been divided into smaller grids. And for each grid, we calculate what is the presence of ships and what are the course and speed they are doing. And based on that, we calculate what is the noise that it is generating underwater. And there are algorithms that do that. And then from the grid, how it propagates in the underwater channel, and particularly taking care of the local conditions. I mean, the tropical waters, as I said, are different. So we have developed those algorithms. We pass the noise of the ships through the channel, and then this is a figure that you get. This particular tool, I mean, I call it an acoustic habitat degradation tool, that can be used even now. A lot of quietening techniques are being proposed by various developed countries. So this can give you a real-time assessment of how these new methods are working. And also you can, I mean, this can also give you various other parameters of fuel efficiency and all those kind of things. A lot of analytics can be done with this. So this is a very easy tool, very low cost tool, but high tech. It can give you updates every 5 minutes, because I mean, as good as the AIS data update, this algorithm works and it gives you output. So these are some of the tools which can really be a game changer as we move forward on the maritime sector. I mean, now it is not just a threat, it is a real thing. I mean, if you look at these three pictures, the first is May 2015, a 40 feet blue whale was stranded off south of Mumbai. Second was a 50 feet bride whale found that was stranded off Karwar. And the third is 90 pilotless whales off Tuticorin. And these are, I have analyzed the first two. The anti-piracy operation has resulted in the shipping traffic moving more towards the coast. So it has a complete, it has disrupted the complete migration pattern of these big whales. And this is a very serious manifestation of the acoustic degradation that we talk about. So there is a lot that needs to be done, and IMO is taking note of these things. And now this is being, but the point is that people are coming with a lot of quietening techniques, but in the overall picture, as I said, the Indian waters are different. So can India take a certain advantage or can seek certain waivers because of the special water conditions? Because it will take us time to migrate from the present system to the next system. So that is what we have presented in this tool. This can give you a significant advantage in terms of policy formulation. And now, any maritime governance maritime domain awareness becomes the key term that is used. But unfortunately, what has happened, this was a term which was initially started by the technical committee of the IMO, but post the 9/11, it became more of a security formulation, and similarly, even in India, post the 26/11, MDA became a very, very important term in the strategic security community. But the problem here was that moments the security community gets involved, the participation of other stakeholders gets limited because of the way security aspects are taken forward. So it is important. And the second more important part is that it has, even for the security, it has remained on surface. There is hardly much being done in the underwater domain. So we have proposed what is called the underwater domain awareness. And here it is quite easy for everybody to appreciate. 4 stakeholders. This is just to give you a rationale that it cannot be too much security driven. It has to have a comprehensive, more inclusive framework. And you can see blue economic entities, environmental regulators, and disaster management, and again, pure science and technology. Just to explain what this means, submarine deployment, both on the offensive and defensive, we had the Kasab incident Do we expect the next attack also to happen by a surface port? There is so much underwater robotics happening and so much can happen. So what is our preparedness? We had a drone incident in the Air Force base, but underwater drone attack is a much easier possibility according to me. Then migration is something, again, we need to be more, from a security threat perspective. A blue economy, I think it's very easy to, fishing industry requires a tremendous amount of underwater domain awareness and technology usage. The fish stock is on the decline since 1996, but the bycatch is of the order of 80%. So how do we regulate this and how do we get more technology into it? Deep sea mining, offshore assets, I think because of lack of time, I'll not spend too much time. So I think it is important. Even from an environment and disaster management, I talked about that standing instance. Disaster management is a huge thing. How do we have more sensors underwater to give us early warning? You can't prevent a natural disaster, but what are the means? Similarly, pure science and technology, it's not possible to map the entire underwater domain, but how do we bring more automation and more of data science and AI robotics to ensure that we have far more data for the entire area, and it has to be a comprehensive, all-inclusive process. Next slide, please. So this is the UDF framework that we have proposed. If you look at all the 4 stakeholders, they may have their individual requirements, but the acoustic capacity building is a very important thing. We have to have better sonar performance, and you can see how all the stakeholders can come together in terms of policy intervention, technology intervention, and also capacity building. We have proposed it to the NITI Aayog, and NITI Aayog is now working with us for a national capacity building project. Even the youth, they can associate, and it's a multidisciplinary framework, which can allow pooling of resources and synergizing of effort. There are breakdown of this into smaller parts like underwater radiated noise management. You can see acoustic stealth is a naval requirement, habitat degradation is a larger shipping industry, and then ship designers and builder. Similarly, for sediment classification, where water resource management on inland water transport, how to keep the waters navigable, it's a very important thing. And there are certain defense requirements also, how to deploy vehicles in the border areas and water bodies. This is the larger framework which allows automation and robotics to come in. We have this funnel and different aspects can be brought in, and on the sides you can see what are the various programs of the Government of India and also what are the core technology requirements, and you can see all the stakeholders on the sides. And if we are able to put this all together, we can get effective policy, good innovative technology interventions and capacity building. So the way ahead, we have to look at a larger inclusive capacity building. I've talked about the involvement of NITI Aayog. The digital ocean needs to be taken up in a different way, and user academia industry partnership is required, what we saw previously, and stakeholder consolidation. We see a lot of fragmentation, everybody doing their own thing. Thank you very much. The next slide, that's the last.
Right. So Arnab, thank you very much for his talk on underwater and various other issues regarding underwater acoustics and the technologies which we have to imbibe and the policies which have to be evolved for making sure that environmentally we are well supported. We have a Q&A session now. I have already a few questions which are already lined up. Since we have limited time, we'll go through the questions very quickly, whatever has come in the Q&A box. The first question, David, I'm sending it to you. It is from a person by name Rajendran Sridharan. He wants to know whether the robo, which is for firefighting, can it do independently firefighting, or will it be of assistance to the crew, who would also have to be in the same compartment?
So
can you quickly answer that?
Yeah. So as I mentioned, it is just an assistance to the crew. It cannot take care of the fire individually or by its own. It will assist in opening valves, laying pipelines, and the hoses, and assisting, going to visualizing on the. So we can show you the fire, the seat of the fire. It can show, but it cannot do anything per se by itself. It will guide the people on board.
There's another question from Mr. Mahesh Parameswaran. He's talking about what automations can be done in dry docks and shipyards for supporting ships. I will take this question. I'll quickly answer. It's possible to use automation by making sure your hull measurement of thickness of paint is possible by using drones, including big compartments. And then there are softwares available by which it's possible to give you a verdict on whether the ship requires repainting or not. Some of these things inside the tanks can be done even when the ship is afloat, so the dry dock time is minimized. Otherwise, the shipyards have got a lot of 4.0 technologies which are there, but that is mostly for production and quality control and other aspects. So now I go to another question, which is for Pradeep Chawla, Mr. Pradeep Chawla. Mr. Pradeep Chawla, there's a question which has come from one of the participants, Sandeep Shivangi. He wants to know whether you are aware that an autonomous ship is being built in India in Cochin shipyard for a Norwegian firm. Are you aware of this?
No, I wasn't aware of that.
Okay. Many of us who are dealing with shipbuilding activities in India are also not aware, but there are some legal issues even if the ship is built for being autonomous in 100%. Can you just touch upon the legal part?
Look, right now in IMO, the regulatory framework is barely starting. I mean, right now we even just looking at which regulations will get affected, and there is a growing consensus that it should be on a separate convention altogether rather than tweaking the present conventions. So what most of the people in the world are looking at is limited use of autonomous vessels in closed shore areas, Norwegian fjords, the Yara Birkeland, which is also kind of delayed, and they see limited usage areas being marked out by individual administrations where these kind of autonomous ships will run. I think generally when we talk about autonomous ships, everybody kind of immediately imagines something happening on the high seas international trade, which is what I think is quite far away. But in the meantime, limited usage, that kind of stuff, in the next 5 to 10 years, we'll have probably hundreds of these small, narrow area, narrow passages kind of thing where they are in a limited location under strict supervision. That's going to happen pretty fast. Tugboats, pretty much delivery boats between two ports which are protected under supervision. That's going to happen quickly.
Okay, thanks, Mr. Chawla. But I just want to add on to what you said. Unmanned surface vessels are already in operation in Israel, in fact with the Israeli Navy, for last 7-8 years. Of course, they are using it for military purposes, but it is quite possible that you can have high-speed military vessels. It's quite possible the concept can be extended to low-speed commercial vessels, as you said, tugboats and other things, which can happen. So one is not very clear what is this ship which is under construction, and automation itself is, the definition of automation itself is not very clear, whether it will completely give an unmanned ship or it will reduce the number of crew. So one has to look at the extent of automation which has been designed into the ship. So in the absence of that detail, we won't be able to confirm whether what is being built in Cochin shipyard is 100% unmanned ship. I have a question for Mr. Rai, Avinash Rai. There's a question from Ankesh Sinha. He wants to know, what is the impact of pandemic in maritime business at ports? Secondly, are the maritime units reluctant to accept automation and instead rely on manual?
Yes, I'm there.
Can you answer this question?
Yeah. So the first biggest impact of the COVID has on the whole maritime industry in the country has been is people have been finding ways of and means of ensuring continuity of business. And how do you do that when the whole chapter is being written every day new? So this is where we have seen a lot of acceptance by every player in the system for any new thing which is being brought in, particularly the digital platforms, the digital connection, and we have not seen any hesitation on part of any of the industry players. Everyone is eager to adopt newer ways. The pace could be different, the actions could be different, but we do not see any hesitation on part of any of the player. Everyone is ready to embrace.
Okay, good. Right. There's one more question for Mr. Pradeep Chawla, and thereafter I'll come back to Avinash Rai for another question. What is the change skill set which is required for the crew? And Mr. Chawla, you have been dealing with a lot of training activities and directing them. Change of skill set which are required for preparing crew to operate or man a highly automated ship. I'm not saying 100% automation or autonomous. Highly activate the automated ship. What are the changes which you think we should be doing, or it's already being done?
Like I said in one of the slides, 5 or 6 of the competencies, this is a topic for a full, probably a separate webinar on it. But basically, people will need to adapt to the fact that all decision making is kind of becoming joint between ship and shore, the port interface and the ship interface. And the other thing is to be able to have an understanding of how to convert data into intelligent, actionable items. A lot of the products that are in the market only bring data to you, but when it comes to actually analyzing that data and making it into actionable items, the different software companies are at different kind of levels of sophistication on that. And a lot of it is presently being left to the human beings to interpret that data, which will also change as we get more and more into deep machine learning, and hence then further on into AI, which will change. But for the present, that is all that is happening with most of the products. Thank you.
Okay. There's another question from Sudarshan Kishore. This for Mr. Avinash Roy. What is the hazards of remote pilotage if we are to deploy these in our ports?
The hazards of remote pilotage are exactly similar what is there on the autonomous cars today. The technology is still getting perfected, that the systems are getting perfected. You have heard Tesla cars getting Ori on a moon night. You have heard them getting Ori on a traffic blinkers. So the technology is getting perfected. I'm absolutely confident as time passes, the technologies will become better and better. Only thing is, nobody is going to risk his asset on a system which is being still proven. So this is the challenge on remote pilotage is, how do you perfect it unless you use it? And the perfection will only allow it to be used. It's a transition which will happen once the technology matures.
Yeah, okay. Thanks. There's a question from Mr. Kamal Chadda. It's on extent of robotics and automation activities which are happening in India. Dr. Arnab, would you like to take this question?
Yeah, the biggest challenge I feel, there are a lot of IT companies also trying to get into automation, but the domain knowledge, where multidisciplinary work is something we have not been able to do very well. And how now, the Ministry of Earth Sciences has also declared the Blue Ocean policy. But I think, there are two major challenges. One is the availability of resources for research. That is a major challenge, and everybody is very fragmented. All the stakeholders are working in their own. The defense is doing a lot of work, but the country cannot afford to put too much money into multiple baskets. So how do we come together to have a collective policy where research is taken forward, pooling of resources and synergizing of effort? Even the scientific community is not so much, because we have not invested so much in the research budget. So I think the fragmentation is a major challenge, and the understanding of where the limits of hardware ends and where the software comes in. That also needs to be focused very, very clearly, because there is a lot today that you can, and the indigenous effort is very, very important. This is a very strategic area. Just to give you an example, sir, the MH370 search, when it started, it took them 1 year for them before they could deploy AUVs for search. It took them 1 year to get high resolution underwater maps.
Yeah, so, and finally the tail landed up in Madagascar's beach. Right, and there are a lot of stories, a lot of theories on where it crashed.
My focus is on the underwater high resolution data. The Chinese are putting a lot of effort in the Indian Ocean. In just 1 year in 2018, they had 24 research expeditions to get high quality data. And this is not just defense. It is for every stakeholder to have any underwater deployment. But the other 6 countries put together, they had only 26 in the same period. So that is, so we have to. That's all. Thank you.
Yeah. Okay. Now, there is a question which has come from Mahesh Buskute. He is wanting to know who should move motion control products contact regarding obviously they should contact equipment manufacturers or equipment designers or ship designers who will do it. I presume MOOC controls are being used in hydraulics or in pneumatics, so they should contact those equipment manufacturers. There's a question from Mr. Das Gupta. It's a very interesting one. I want Mr. Pradeep Chawla to answer this. Is the build, own, operate concept, is it picking up globally to a consortium of designers, shipbuilders, owners, and shipping agencies?
I'm not sure that I really understand the question clearly. In shipping, build, own, operate is not a model that generally exists. You go to a shipyard and you order your ship and you get it. So I'm not so sure of what the question is really about.
The question was whether this is an emerging concept which is coming in. We get another view on this. David, would you be able to comment on this? Build, own, operate?
Not too much, because as Captain Chawla says, it is not really a concept which owners are into or even the shipyards are into. I mean, it is just that we order a ship, the shipyards have ready-made templates, so we have to order as per that, and probably a few innovations here and there. But build, own is just not a concept which has caught on anywhere. Maybe Mr. Das Gupta has something more to add to that question. I'm not sure.
Yeah. Right. So there's a question which has come from Mr. Nikhil Roy. He wants to know what are the technologies which require attention to ensure seamless connectivity between vessels at sea with their offices, shore offices or control centers on land. I will answer this very briefly. We have a shortage of time. Obviously, it has to be through satellite communication, and there are many inexpensive, at the same time very expensive ways of having satellite communication. It depends on to which network you want to choose, and it has to also depend upon the bandwidth that you're looking at. I would think ships which are monitoring data or ships equipment which are monitoring data should be analyzed to some level and made a little more compact before the whole thing is sent ashore for further analysis, archiving, as well as doing trend analysis if it's required. I will just give an example of a French ship. I'm talking of a French warship, which has got a similar system of automation, like David said. It monitors all the data from various sensors, engines, the vibration, their temperature, the fuel consumption, etc. And they compact the data, and once in 12 hours, they upload it through the satellite and send it to their control center ashore for further analysis. So you avoid sending a very wide or a big packet of data which has to be completely analyzed right from start ashore. So this could be one of the methods. Otherwise, you'll have to spend a lot of money in sending a whole lot of data from sea, which could be economically controlled. Now, there is a question. I think, David, I'm giving this question. There's a question from Ajay Achudan. What would be the future with respect to robotics and artificial intelligence for existing personnel? Do you think the existing professionals are competent to handle issues of robotics and artificial intelligence in the future? You can try. Otherwise, I will ask Dr. Das to look at this.
So to answer this question very pragmatically, first of all, we find that the existing ship staff or the officers are lacking in competency to handle today's equipment. Obviously, when you talk about AI and other automation and intricacies, it is far-fetched dream to expect this. But of course, we'll have to have enhanced training. Captain Chawla has been pioneering on all the training, and I'm sure as and when this come in, there will be a lot more training and innovative training which will be added to the existing curriculums, which IMO and other bodies will also get involved in. So at the moment, the ship staff, as to answer the question very briefly, are not capable of handling such modernized equipment. They will have to have enhanced training right from the inception, or the pre-PC training, and then also as value-added courses during the course of their competency exams, etc., etc. So there is a lot of work to be done, and of course, very pre-formative stage now, or even not even a pre-conceptualized stage. So we are a little away from.
Right. So before I come to Das, I would like to add to what David had said. Artificial intelligence or robotics are essentially improving the manual process, or which can be supplemented by this, okay, or substituted by this. It is more on developing this systems, robotic systems, artificial. It's more of a designer's job. It's more of IT job. And they need not be seagoing, but they need to understand the process very well before they design system. Last, can you just add? Because in submersible, there's a whole lot of robotics and artificial intelligence which is being deployed.
Sir, actually, I mean, as all of you have said, it is a fragmented approach. So that, I mean, firstly, for the operators, there's a lot of inertia to embrace new technology because safety issues are paramount. And the two communities are very fragmented. I mean, the people who know data science, they don't understand the ships, and people who understand ships, they don't. And the multidisciplinary effort where we can come together and work has been a huge challenge. How to kind of take it forward. And secondly, the deployment of resources. I mean, everybody is so fragmented that the money for research is extremely low. People have not been able to pull in resources and synergize their effort. And this requires a sustained effort. I mean, we can't get quick solutions. I mean, for any AI system to work, there's a lot of data required, but the data is not available. So it is just going into a catch-22 situation. Okay. So a lot of long-term sustained effort is required to kind of take it forward.
Yeah, Mr. Chawla, there's a clarification which has come from Mr. Sudarshan Kishore. He says the shipyard, which is the Cochin shipyard vessel, which is under construction, is a joint venture between Kongsberg and Wilhelmsen, and it uses the concept of autonomous engine. So it's only for maybe propulsion or propulsion control, and which Kongsberg has developed for some Norwegian defense ships. And the ship will sail with full crew till it reaches Norwegian waters. So it answers partially that this deployment of this ship with some automation or autonomous mode may happen only in the local waters of Norwegia and not in the blue water and the international waters. It could be something very specific for this. I also am aware that they have been trying to have, I'm not sure whether it's the same JV or not, but they were trying to have a diesel engine plus a wind energy driven, which is automatically controlled. The sail is automatically controlled. That was also under development. So I don't know whether it's the same ship. Now, there is a question which has come from, name is not mentioned. It says the design value added courses for seafarers so that they're ready. I think you already answered this question regarding autonomous ships. Mr. Chawla has already answered. Now, Ajay Achudan says that monitoring of competency or ability to monitor has to be enhanced. Now, monitoring the webinar or monitoring the functioning of machinery in the ships, I'm not very sure, but I would presume it is about monitoring the performance of machinery on board the ship. Obviously, it has to be monitored locally in the ship itself, and the ship also, there is a local indication next to the engine. There is a remote indication in the engine control room. You can upload it through satellite, either live or with offline with some delay of 4-5 hours for analysis as show. That is a choice which has to be taken by anything which has to be done live, like it happens in spacecraft, is going to be very expensive. So I presume it is something which the design has to look into. But the question is not very clear, Mr. Achudan. There's a question from...
So I think the question is regarding the competency of the people handling on board, whether it has to be enhanced to operate such equipment.
Okay, I was under the delusion that it is about competency of people who are monitoring the webinar. So I was
basically additional training or incorporating their pre-C, I mean the training curriculum, etc.
There's a question which has come from Akhori, and I think David, this is for you. It is for DPS vessels and offshore supply vessels. They use satellite and servo mechanism to make the ship stable. It's a kind of autonomous system. is this something like this cannot be used for remote pilotage? It's very technical in nature. It is not about the end use, but can we extend the technology which is being used in DP to remote pilotage of ships when they come alongside? Okay, would you be able to? And second question, second part of the question, Mr. Chawla, is there any thought process on classification society? How will they classify autonomous vessels like they classify DP as DP1, DP2, etc.? So first David and then Mr. Chawla.
So as far as I know, I have not heard about this concept being used for the remote piloting of the ships. That's a different concept entirely. So I think these are two different technologies. So and that's more advanced, the remote pilotage or autonomous pilotage. So that is the DP ships are, I mean, they are advanced, but they are not so advanced to use that technology for remote pilotage. So I'm sure that this is different. They are two different technologies.
Yeah, Mr. Chawla, what about DP vessels classification? You have some classification. Is there any talk already about autonomous ships being classified in some manner?
Yes, there is. Lloyd's registered, DNV and ABS, etc., all very much into it, and they have been participating in all the IMO committees about it. Lloyd's came out with their own classification, which was 6 levels versus the 4 levels in IMO. So I don't think they are going to be far behind in classifying ships, and the regulatory framework will take a little bit more time before the rules become common. And all the major classification societies are very much at the forefront of research, and DNV in the Scandinavian cluster is very much involved in all the new stuff that is coming from there. And they hold a wealth of knowledge about it.
Okay. Now, most of the questions are over. There's one more, which I'll come to a little later. But before that, Avinash, I want to ask you a question regarding ports. The question is from me. There's a lot of talk, or at least there's a lot of literature which has been published, which is also touched upon in Maritime India Vision document. The way cranes are designed, or the software of the cranes are being developed, where they can be either dual cycled, or the number of operations in 1 hour, how they can be increased so that turnaround time of ship is reduced. Now, can you tell what is the extent to which dual cycling of cranes or the number of operations in an hour have been addressed in Indian port? And one of the best ports are the modern ports are well within your knowledge. Maybe it's with your group as well. So, Ms. Avinash, can you just answer that question?
So this is a classic case of efficiency by reducing the empty cycles. So as the computers are becoming powerful and as the technology is becoming powerful, today everyone across the world is looking at how do you reduce your empty cycles, thereby reduce the vessel stay at the port. And this is a trend which is going to accelerate only on two fronts. One, efficiency, reducing the time, and as well as reducing the electricity or diesel consumption. And it's happening. The percentages are increasing every day across the world in all the terminals.
Can you give an Indian specific answer how we are as far as dual cycling and
today on dual cycling in India, on some of the terminals, we can see a percentage which is close to 10-12% out of the possible 40-45%, which was zero a couple of years back.
Right. There is something which I read. I was quite surprised. Industry 4.0, which has got a lot of application industry, has got customized for shipyards. It became shipbuilding 4.0. I had a lot of personal experience on that. Now I see there's a Port 4.0 package which is being talked about. Is it in application in India? The ports are automated with 4.0?
No, in India, I think we are still at a stage where we are maturing. We still have a path to go. We still have a distance to go. But I can only assure everyone, one, all the Indian ports are as competitive as any international port even today in terms of productivity, in terms of throughput. The equipments are very similar across the world. The performances are very similar across the world today. The gap is very minimal.
I just want to ask Avinash one more question. All ports are supposed to have a certain level of oil spillage control. They are supposed to have equipment for it. Do we have robotic equipment for oil spillage control in Indian ports?
I have personally not seen across any Indian port a robotic equipment, but I can tell you every port is having capability for control of oil spillage. Everyone is responsible for maintaining this facility to ensure spillages are controlled in case of an accident.
No, it is manual.
It's manual.
Okay, good. Now, we just a couple of other questions which have come. One is for Pradeep Chawla. When you bring in automation, the crew strength comes down. Now, the choice for ship owners or shipping companies is more automation and less crew, or less automation and more crew. Which is the thing which they favor? Because you give employment for more people if you have more crew. What is the trend which is?
Yeah,
this question has come from Sanjeev Vakil.
Yeah, we do have 31,000 seafarers now, but what is very likely, this would be my prediction, what is likely to happen is that within the next 5 to 10 years, we will be reducing the crew on board, meaning the bridge, like the engine room going UMS, we will have something like the UBS, unmanned bridge operations, which will start with something like the technology is there, you don't need to do anything, don't touch it. And slowly it will be that you need not be on the bridge and you can be in the cabin. And the next stage will be that even during nighttime, you're only on an emergency call and the autonomous system will, give you an alarm like in the engine room. How quickly this is going to happen is anybody's guess, because any automation that has come into any industry has always reduced the number of people, but it has improved the process and it has made the costs go down. So that is unstoppable in the maritime industry, port industry, any industry, that as we get more and more AI, deep machine learning and all that, we are going to replace human beings with process improvements with these robotics and with software. But does that really make a difference? No, we as ship managers will change our way of looking at things, and we will be providing services where we will be the remote operators for the ships sitting in Mumbai. I mean, that would be a wonderful part, to come back to Mumbai and operate ships from there remotely, right? I mean, why not? And yes, like I said in my presentation, India needs to think about that very seriously. And we today are pretty much amongst the top 5 crew supply nations of the world. And we are a well-respected nation with the quality of our officers. So why don't we be ahead of the game and actually start looking at putting the right things in the syllabus? I was reading, as Ajay has pointed out, it's for us to get together, sit with the Director General of Shipping and start introducing these subjects into the pre-sea training, into the competency examinations, and make people try and do their diagnostic fault finding, no longer from touching and feeling and the old engineers talking about, I can hear the bearing making noise. No, that's finished. Now you need to look at the screen and do your data analysis and your analytics and diagnostics. So why not change the examination patterns so that we actually give them situations where they are looking at a simulator of ship and actually looking at solving these problems as part of their assessment. So things like that will need to be done pretty much quickly if we want to stay as a supplier of autonomous support groups. There is offshore business outsourcing has already, India has been a leader. So why not in shipping too? I think we can do it.
Okay. Arnab Das, I'll come to this question to you with cyber threat to autonomous ships. But before that, let me ask David, maintenance cost of autonomous ships. do you have an appreciation? Will it going to be very high? Because a lot of these software-driven packages and their fault localization and any rectification, etc., may be very expensive, and which can be done only by high-tech companies. So do you have an appreciation on the maintenance cost?
I would say the other way around, because I think probably the capex cost may be high in the beginning because it's new technology, etc. But once it comes into place, it first of all will be more reliable. So all this cost of breakdown, maintenance, etc. will come down drastically. And even if it has to be done by experts initially, till the ship staff become familiar or even the dry docks become familiar, it will still be a much lesser cost because of the the frequency of repairs, and as I said, breakdown maintenance will be far less. It will be more of the the monitoring and the timely maintenance and repairs. So, that is some subject which will bring down the cost rather than enhance.
Right. So this is a question from Mr. Sanjeev Vakil, but I have another question from Shiv Halbe. Do you think, Pradeep Chawla, do you think we need to improve upon our syllabus of training packages which will include all these automation and robotics? How do you plan to do it in your training programs?
Well, I cannot but agree with my good friend Shiv that yes, we need to get rid of redundant items in the syllabus. I mean, sometimes when my staff tells me about the kind of questions that they are being asked even today in their oral examinations and in some of the written questions, I do feel that we do need a change, but it is for people like Shiv and all of us together to influence the regulators into modernizing our syllabus and our training. So I think we together need to work with the administration. My experience of working with different administrations around the world is that the Indian DG is actually very, very cooperative. I've never had a problem in being able to explain something in the DG office, and what they lack is sufficient resources to handle all that. And the fact of life is that to attract the best brains out of shipping into DG shipping is difficult because of the wage structure of the government.
That's right. Yeah.
But we have talent in the country, and all of us who are the end users, we need to contribute and give it on a platter to DG, so that then there is a debate about it internally. And this is one of the issues that does happen, that when you have too much of debating and no results, things don't get done. And that, I think, we as an industry need to take the lead and not the regulator. And India has been very cooperative in all of the things that we have approached them always. Never a problem.
Okay. So we just have last questions. I think at some point of time, we need to close down this webinar. So I come to the question on cybercrime. Arnab Das, what do you think is a threat to an autonomous ship through cybercrime?
The complete digitization or coming on board a digital platform has significant vulnerability to, and the transition has to be very well thought out. I mean, like Mr. Pradeep Chawla had also talked about regulatory protection. I mean, you have to have those tools, and it has to, right now what we see is it's a very half-hearted transition. So, and it has to be done at all levels. Policy intervention, technology intervention, and capacity building all have to go together. And it's always the attacker is ahead of the curve and the defender is far behind. So we have to look at it in a very, very different manner. And the transition has to be very well thought out. Otherwise, it can create more problems than improving the efficiency.
So what you're saying is cybercrime is a feasibility.
Absolutely. Anything
digitization,
even documentation, when we are digitizing it, it is so much more vulnerable if we have not taken enough precautions.
Yeah, I tend to agree with you. You said MS-370 some time back, and there are many stories on how the aircraft was taken on remote control and flown to another location. It was possible by technology. So similarly, you can take control of the autonomous ship and take it to some other place. It is possible theoretically. We really don't know how hardened the system would be to prevent such cyber attacks. Okay, the last question is from Saurabh Kumar Akhori. He is saying artificial intelligence and machine learning are process changes, and which would mean the developers will have to work out the algorithms which are required to be incorporated, and therefore it has to be based on a lot of study and a lot of data collection. And are we doing these things? Let's talk about ship first. Are we doing these things for ship automation? Are there efforts being made for data collection? So I will just answer this question. If there's anything more to be added, I open to the panelists. Anyone can join. See, some time back we said a lot of data is being collected and a lot of data is being monitored locally on board the ship, and thereafter it is dumped offshore either through satellite, and in case of ships which go out only for a short period of time, when they come back to port, they hand over the data to their shore office. Just for information, every airline at the end of the day after its 5-6 flights, an aircraft, it hands over the data, it downloads the data and gives the shore office for them to analyze the fuel consumption, all various aspects of navigation. Has there been any near miss during their operation, etc., safety aspect, everything is more analyzed. So data is collected, and as a part of solution to some other situations, the algorithms are worked out. So similarly, for ships which are going to be out at sea for a long period of time, satellite link is an answer. And there are expensive ways of doing it. There are inexpensive ways of doing it. This has already been talked about by Mr. Pradeep Chawla in his earlier talk. So data is being collected and algorithms are being developed to make sure that the right level of automation is, we're not chasing automation just for the sake of automation, but the right level of automation is being inducted so that it is safe, it is reliable, it is efficient, and at the same time, it can be reversed to a manual operation easily on board the ship in case there is a situation that it is not performing actually to the level it was designed. So that question is very clear. The answer is also very clear. This is the way algorithms are developed for such systems. In case anyone would like to add to this particular aspect, kindly do. Arnab, you can talk about in submersible how it is being done, where data collection is not so frequent and not so easy in case of underwater submersibles. But before you touch upon that, Pradeep or David or even Avinash, for port operations, is there a trend going on to collect data, to analyze and bring in automation in a progressive manner? So first I'll open to Pradeep, then I'll go to Avinash, and then I'll go to David.
I think you've answered it sufficiently. I mean, all these things are not the major insurmountable things, and while the cost of data transfer right now may not be at a desired level by the ship owners, it's not really an issue. We have ships in the offshore industry who are sending 20 gigabytes of data in a day. So it's not really, there is no problem with the capacity of satellites to be able to transport it. It's more to do with at what time does and how much data do you really need to make insightful, actionable items out of it.
Yeah. Avinash, for port operations, are we, because there is some, these days they're saying track your containers using satellites and bring in some automation to make sure logistics are more efficient in ports. And there are ports which are implemented, as we talked about earlier, 4.0, port 4.0 to make it. So data collection, is it become a regular exercise for ports which are looking forward for further automation?
I think what you are saying is a very right practice today, where incredible amount of data is being generated. Everyone in his business has started looking at the data to find value in it. And what are the values? The values are the processes, the values are the times, the values are the timestamps, which allows anybody and everybody to look at how do we cut down the times. For example, the Indian Customs is looking at time from the time the vessel has landed to the bill of entry is granted. Somebody is monitoring the container trains or the containers from the time they landed at the port to the time they have landed in an ICD in Delhi. Somebody is trying to look at the whole TAT of the trains. So everybody is looking at with a basic premise that if you can cut down the time, you bring in money. If you can cut down the processing time, you release the goods faster. Indian Customs has been a pioneer in this, in bringing an efficiency by reducing the time for bill of entry clearance from the time box landed. So everyone today is using data in some shape, size or form. And that's a practice which is going to improve. Today, every container in the country, Mr. Kannan, is being tracked by DLGB with an RFID tag where it is being looked across the country and you have a visibility on a DLGB portal.
Okay. So the people who are running in this, they have faith that automations have given good results and they're collecting data, more data as required to bring in additional automation.
Absolutely.
So it's a good trend.
Absolutely.
Okay. David, would you like to add on before I go to Arnab Das?
Yeah, so basically fully concurring with Captain Chawla, and of course all the companies are looking and also ship operators at their data and doing trend analysis to look at what can be the problems and you know what are the trends showing why the breakdowns are happening or what typical equipments are failing, etc., etc. So all this data collection and data assimilation and data inference is being done on a big scale. Classification societies are also ready to assist the ship owners to handle such data and assist them with inference from there. So that is something which is happening and it will happen more and more.
Okay, last word, Arnab. You tell in underwater submersibles where opportunity to generate data is not so often or requires specific lot of efforts to ensure you have a mothership, you take a submersible to sea, then lower it and then allow it to operate and generate data, maybe through fiber optic umbilical or through onboard storage, which is retrieved later. So how is the data being collected so that it supports further automation for robotics? We close this webinar with your comments.
Thank you, sir. Sir, I would like to give you an example of what was called Asia X. I mean, we call it shallow water acoustic measurement, particularly in the tropical waters. In the South China Sea and East China Sea in 2000, the American establishment conducted what is called Asia X. Largely, and before you actually go for data collection, first you have to spend time to do the modeling and simulation. I mean, data collection is only a validation. I mean, for any data collection effort, first you do the modeling because you can't collect data for the entire ocean. So you build certain models and only for data collection is done only for validation of the models. And once your models are validated and you can put certain assumptions, this can be used for a larger, I mean, that synthetic data can be used for a larger
so is it based on fiber optic link?
No, sir.
Umbilical or is it?
No, it will require acoustic sensors of certain specifications. If you are doing a
the recording of data is inside the submersible, or is it through an umbilical fiber optic to mothership?
No, sir. With an umbilical fiber optic cable, you will not be able to cover large distances. Now, even underwater gliders are being used, which are far more. And now the data, I mean, the memory capacity has really enhanced. And also, we look at processing on board. So then your data, the size becomes reasonably small. So there are multiple kind of strategies people apply because it is not, if you start transmitting data, then because the larger challenge is of power. So if you start transmitting too much data, then your endurance will go down. So depending on how the experiment has been planned, you will have to do it in a slightly different way. So Asia X was in 2000, and in 2015, China announced what is called an underwater Great Wall project. These are all underwater data collection kind of strategies. And this has to be it is almost like a superpower game in the underwater because the amount of resources required and kind of know-how required is not so easily available in the scientific community, and particularly the field experimental kind of effort. So, I have not seen anything like Asia X, and now China is doing a lot of work, and they have built it over the last 30 years. So you have to have a long-term focus and a whole lot of asset deployment, which is a very, very high value game. So, will you be able to sustain such big budgets? So the best way is, if I talk about Indian Ocean region, the best way is all the countries in the region coming together, like platforms like Indian Ocean Rim Association or something like that, coming together, and probably in the Indian Ocean, India can take a lead and take this forward, where everybody, and there are diplomatic issues also. Will you allow somebody to come and do data collection in your waters? So there are aspects of geopolitical issues which needs to be done. Thank you.
So we had a very good webinar. We had the speakers sharing their expert views on the topics of today's ships, tomorrow's ships, ports, and even on underwater domain. And before I hand over platform to the host, I just want to thank each one of you for your valuable contribution through your talk, through your question answer. We had a very long question answer session for nearly 50 odd minutes, and all the questions which people had raised, we have tried to give an answer to this. But in conclusion, ships automation has progressed very well over the last 25, 30 years when digital technologies have started coming into equipment, and it has progressed. But I think it is just going through a plateauing now, as per me, before it takes the next big jump of what is autonomous mode of operation, which will be a totally different sort of ball game. As far as ports are concerned, the automation is on the rise. Robotics has not kicked out so far much in the ports, except for some oil spillage control, etc. So automation in ports is increasing. Even in India, it is increasing. While in underwater, there are many things happening, but it is not so much in public domain, because many of the applications are strategic by nature, be it with respect to ocean mining or with respect to security missions. So therefore, the developments which are taking place are not available in public domain for people to discuss, but there is a fair amount of development taking place, and these are all depending upon whether countries want to have more and more underwater domain activities, which they would like to use for both economic as well as for security purposes. With that, I bring the webinar to an end. Can I have the host back on the screen to just thank him, and then we can leave the meeting.
Thank you.
I finished the webinar. All the questions which people have asked, we have tried to get our experts' view on that. They may be partially satisfied, but I think it was a very good session where we could bring update to people on what are the trends in marine automation, trends in marine robotics, and to a certain extent, how it has happened in our assets, marine assets, be it ships, be it ports, or to a limited extent, be it in submersibles. I just want to thank you on behalf of all the panelists. Thank you very much for hosting this webinar. Thanks a lot.
Thank you, Admiral Kannan. And
Admiral Kannan, with your permission, may I come in for a minute?
Okay.
I have been, of course, listening to all of you with great interest, and also to the questions and question answers. Now, you have done absolutely a wonderful job, but since you have gone well beyond the time limit and have virtually taken up each and every question, I thought, why deprive the last person who has put in a question about piracy? So I thought, let me at least give a comment on that question as well, so we can claim that this webinar,
sure.
100% of the questions have been at least answered. Whether to the satisfaction or not is a different question, but at least we have answered. So my take on that, the question is that fully autonomous vessel can be boarded by the pirates. The pirates can disable the automation and manually take the ship away. So what happens? Now, my answer to that after all, we in the maritime industry, of course, the shipping assets are extremely valuable assets, worth millions of dollars, etc. But we don't consider our, lives on board, the seafarers on board, any less valuable. If at all, I may say they are even more valuable. So I think in that sense, it is less of a danger. Because in any case today a ship, manually operated. Of course, no ship today is completely manually operated. Automation has been there for long. We are only talking of the fully automated vessels. That's all the extent. But today, a vessel which is partly automated and of course has a full complement of crew, I would say they are more vulnerable. Again, if the pirates actually take control of the vessel, they have the control of the asset as well as the control of the lives on board. So at least on a completely automated vessel, that problem is not there. So to that extent, I would say we are reducing the problem and not in any way adding to the problem. So I thought, as I said that you have done a wonderful job on behalf of the organizer. Of course, Ranjit will speak, but as in my capacity as the chairman of the advisory board and in my personal capacity, let me also thank you profusely and thank all the speakers for their wonderful presentation. After all, science and technology is meant to improve the quality of life, and if I may say so, not only the life of human species. We are only one of the thousands of species on this planet. So the science and technology must add to the quality of life for every species on the planet and for the sustainability of the planet as such. And it is more important because the pace of change is really gaining momentum all the time. As we see that the changes, particularly in the space of science and technology in the last couple of decades, may have outpaced the preceding century, and the century has preceded possibly the changes over a millennium. So obviously we have to be, and as Mr. Chawla has very nicely brought in, everybody has brought in, that we as the seafaring supplying nation, after all, our Indian fleet is just about 1% of the world fleet, but we contribute nearly 10% of the fleet personnel to the global fleet. So obviously as that, and for the after all, we are the only nation, I keep saying this in all maritime seminars, we are the only nation after which an ocean has been named. We talk of Indian Ocean region. That's the only, we can talk about it with so much of pride. So anyway, I will not take any more time. We have already exceeded that time. So I would conclude by once again thanking you personally, Admiral Kannan, and all the speakers. Thank you very much.
Thank you very much. And this is the gift for me, Mr. Hazara coming here. And I am so happy, Mr. Paul, that I could get to meet him after so many years. Right?
Thank you, Admiral Kannan.
Thank you,
sir. Thank you very much to all the panelists for an enlightening session. Thank you, Mr. Pradeep Chawla, Mr. Avinash Rai, Mr. David Biratkar, and Dr. Arnab Das, and our esteemed moderator, Vice Admiral Kannan, for steering this discussion so wonderfully and taking all the questions. And a special thank you to Mr. Hajra for his presence, and he, along with our advisory members, have been instrumental in advising Informa on the webinar topics and the speakers. And going digital with adoption of automation and robotics will be the solution for many concerning problems and help shipping companies stay competitive in increasingly challenging times. Technologies will reduce carbon footprint in shipping and ports and provide better customer service with information about the location, the time of arrival, and delay in shipment. While it takes several years before it really impacts the industry as a whole, it's clear autonomous ships will be the reality in future. So thank you to our wonderful audience for being with us today, and hope you enjoyed the session and had a great takeaways. We invite you to register for the forthcoming webinar on leveraging the disruptive power of 3D printing and additive manufacturing, same time next Tuesday. Till then, goodbye, stay safe and stay healthy.